All right, we're going to start taking a look at a few other ways that we can analyze systems of equations or ways that you might see systems of equations. So the other way that I've got here is by tables. So if you've got tables like this, we can look and notice a few things. Like I've got some common numbers there, but I really want to check and make sure that this one's not infinite solutions where all the values would be the same versus just one solution. So to do that, I need to figure out my equations. And the way we're going to do that today is just by using Desmos. So what I'll do is I'll take, and in Desmos, I will put in those values for my first table. So -3, 0, 3, and 6. Then 2, 3, 4, 5. And I can do a linear regression, which is just typing in y1, then that squiggly line up by the 1, mx1 plus b. And what that's going to give me is a slope and a y-intercept. So that slope, 0.333, we should know that that is the same as 1/3. So my equation for that first line would be y equals 1/3 x plus 3. And I'll do the same thing for that second table. So what I want to do first here is before I do that, I'll just put in y equals 1/3 x plus 3. And what that does is when I delete all these values, it's going to leave me a line there that I can view. So I've got that line there. Since we're putting it in Desmos, it'll be helpful to kind of see the graph as well. So then the next one I have -3, -1, 1, and 3. And I've got -2, 0, 2, and 4. So nice thing is I've got this typed in. It already gives me my linear regression. I have a slope of 1 and a y-intercept of 1. So that means my equation is y equals x plus 1. So my slopes are different. That means this is going to be just one solution. And that one solution would be the one place where they are exactly the same. So if I look on my table, I've got that 0.34 there. Or since I put it into Desmos, I could also just look on Desmos and say, oh, it looks like I have that point right there, which is that 0.34, where they cross. So that would be our solution. Either way, that solution is 3, 4. Next one I'm going to look at, and I'm not going to type in all of these on Desmos for you. So we're looking for the equation. We find the slope. If we were to do this, it goes up 1 there and up 1 there. So it's a slope of 1. I actually have my y-intercept there of -2. So y equals
All right, wish me luck.
x minus 2. And then for my next one, we work that one out. It's going to be y equals x plus 4. So looking at those, and if I put those equations into Desmos, what you're going to see pretty quickly is they've got the same slope, but a different y-intercept. And so when that occurs, you have x plus 4 and x minus 2. So I've got two parallel lines. So just like on my graphs, when I've got parallel lines like that, that means there is no solution, or NS. They never get any closer or any further apart, which means our last one should be infinite solutions. And those infinite solutions would be that I've got these tables. If I put them in, figure out my slope and everything, you end up with y equals 1/3 x plus 2. And we actually end up with the same thing, 1/3 x plus 2 for my second equation. So those end up being exactly the same. And notice they won't give you many at the same points, if any at all. So even though these tables look totally different, they increase and decrease at the same rate, and they both end up with that same y-intercept. So those are using tables for that. You'll see that every once in a while, but if we know how to put it in Desmos, that'll be most helpful for you. Okay, our last way we're looking at today is going by elimination. So when it wants to know what is the solution to the system of linear equations, what I can do now is there are some tricks that we can use to kind of combine these equations and add them or subtract them from each other to actually give us a solution. So looking at these two equations, I've got them both in standard form. I could change them to my slope-intercept form and graph them, but looking at dividing by 7, I'm going to get some weird numbers there. So there are some other options we have. One of those is using elimination. So since I know I'm looking for the point where these are the same, that means I'm looking for the place where these are both equal to one another. So since I'm looking for that place where they're the same, I can actually add or subtract these from one another, and I'm going to end up getting some more information to help me find that point. So first thing I notice here, I've got an x on the top and a negative x on the bottom. Then since that's the case, if I add all of these together, I would be doing x minus x, which ends up canceling both of those out. So if those cancel each other out, then I would do 7y plus y, which gives me 8y. And so we'll say x minus x give me 0 x's plus 8y equals 17 plus 7 or 24. So that 0x goes away, we don't need it. Oh, I'm just left with 8y equals 24. Then I have a simple one-step equation, and I take and divide everything by 8, which gives me 24 divided by 8 would be 3. So now that I know that y equals 3, I can take and plug that into either one of my equations, and it's going to give me the answer for my x value. So I'll use that second equation of negative x plus y, and my y is going to be 3 now, equals 7. So just going through my quick couple of steps to solve for x this time. So I'm adding 3. I'll subtract 3 from both sides. Gives me a 4 over here. Equals negative x. And so if I divide by negative 1 on both sides, changes that to a positive and that to a negative. So my x value is going to equal a negative 4. So those two together gives me my solution. That coordinate pair would be a negative 4, 3. And I can always plug that into the other equation, make sure it's true. If I did negative 4 plus 7 times 3 should equal 17. That's 21 minus 4 does equal 17. So that works as my solution. That's just a quick double check to make sure it works. Okay, on my next one, you won't necessarily have these work out where there's nothing you have to do to them. So that one happened to work out. For this one, I need to find something that I can make cancel out pretty quickly and easily. So looking at it, my y's, negative 9y and 5y, I'm going to have to do a lot of multiplying there to get those to something that cancels out. But for my x's, I have a 4x there and just one individual x there. So what I can do is I'm going to take and multiply this whole equation here times negative 4. So what that means is everything that's in here is going to get multiplied by a negative 4. So let's do this first. I'm going to rewrite my top equation, 4x minus 9y equals negative 42. And then let's go through and multiply each part times negative 4. So negative 4 times x gives me a negative 4x. Negative 4 times 5 gives me a minus 20y. And negative 4 times 4 gives me a negative 16. Now I'm going to combine these two equations. Should be 4x minus 4x leaves me with 0 x's. Negative 20 and a negative 9 gives me a negative 29y. And negative 42 minus 16 gives me a negative 58, which is hopefully just double of that, but we'll see. So I have that canceled out. So what I end up with is negative 29y equals negative 58. Well, if I divide those out, those cancel, and I end up with y equals, let's see, 29 times 2 does get me to 58. So that would just be y equals 2. And then we're making the decision of which one of these I want to plug in that 2. So looks to me like the second equation might work out a little easier. So I'm going to take the y and plug it in there. So x plus 5, now we're going to do y is 2, equals 4. So 5 times 2 gives me 10. So something plus 10 equals 4. Figure that out. I just subtract 10 from both sides. And I end up with x equaling negative 6. Same thing, I could plug this in, a negative 6 there, a 2 there, give me negative 24 minus 18. Looks like it's getting me to that negative 42. So my solution here would be negative 6 and a 2. So you notice on these, we're getting one solution that's what happens most of the time for us. And looking at this one now, I've got some that I can't just multiply 2 times something to get to 5 or 3 times something to get to 7. So in this instance, I've got to multiply both of them by something. And so the easiest thing to do here is just to pick one and multiply from that.